Section 10.3. Ellipses. Definition. An ellipse is a set of all points x, y in a plane, the sum of whose distances from two distinct fixed points, the foci, is a constant. So we have two focuses, right? So they call it foci. From two distinct fixed points, foci is constant. So imagine that you have a string, right, between these two foci. And if you stretch the string with a pencil and then kind of just draw all the way around, right, as far as the string allows you to, that will draw you an ellipse. Notice the different components of an ellipse. There's a center. Of course, there's foci, right? There are two vertices, vertex, on the ends there. And this is on the major axis. So when they talk to you about a vertex, it's on the major axis. But there's also a minor axis for the narrower part of the ellipse. And it depends which way your ellipse is elongated, right? It can be long horizontally or it can be long vertically. So keep that in mind. Your major axis is the longer side, longer length. There you see the picture of the pencil. And this talks about how they derive the equation for an ellipse. So you can see they're using triangles and distances and things like that, Pythagorean theorem, etc. To come up with these standard models. Standard form of the equation of an ellipse with center HK. So HK previously was the vertex, right, of a parabola. Here it's the center of an ellipse. And major and minor axis of lengths 2a and 2b respectively. So the length of a major axis is a units on both sides from the center. So that's 2a. And the measure of the minor axis is b and b on both sides of the center. So altogether is a distance of 2b. And b is less than a, right? Because the minor axis is smaller than the major axis. We have a formula for when the major axis is horizontal. So this is an elongated horizontally ellipse. Notice the difference. The a squared is under the x minus h. Whereas for the vertical major axis, the a squared is under the y minus k, right? So when your ellipse is elongated horizontally, the larger length goes under the x term. The larger length goes under the y term when it's a vertical elongated ellipse. The foci lie on the major axis always. They are c units from the center. So we would have to find the value for c and then measure that distance from the center of the ellipse in both directions to find where the foci are. And the formula would be c squared is equal to a squared minus b squared to find the value of c, okay? A being the half of the length of the major axis and b being half of the length of the minor axis. And c is the length from the center to the foci, to the focus. If the center is at the origin, then of course you won't have a h or a k, right? Because hk is the center of the ellipse. So if it's centered at the origin, then h is 0 and k is 0. So your formulas would simplify to these much smaller expressions. Excuse me. And of course, notice how everything's set equal to 1. So we'll use those formulas to kind of figure out all the different things they're asking us. But here's the general view of these ellipses when they're horizontally stretched and vertically stretched. Notice here, this is the major axis. So A, B, B. Vertically, this is the major axis, vertical axis. So this is A, A, B, B. Let's start with, should we start with 1? Yeah, let's start with 1. Example 1. We're going to find the standard equation of an ellipse. What we know is that the foci are 0, 1, and 4, 1. And the major axis has a length of 6. Major axis of length 6. The total major axis is actually 2a, right? The total measure, right? So whatever the major axis is, you know it's AA, so it's actually 2a. So 2a is equal to 6, which means A is 3. Okay. So what do we know? So let's kind of sketch it out first. So we know the foci are 0, 1, and 4, 1. Because we don't know yet if it's a vertical or horizontal one, right? So 0, 1 is here. 1, 2, 3, 4. 4, 1 is here. So because they're lined up horizontally and the foci are always on the major axis, we can see that this is a horizontal ellipse. So something like this, right? Just a sketch. From here, we could probably find the center. What's the midpoint in the middle there? So if this is 0, 1, and this is 4, 1, in the middle would be 2, 1, right here. Good, so our center is the 2, 1. They had told us that the distance from the center to one of the focuses is our C value. So how many units from the center to one of the focuses? So for example, from here to here is how many units? 2. And that's going to be C. Single C. We know A is 3 already. And we can actually find B from the equation for C. Since C squared is equal to, what did they say, A squared minus B squared? We know that C is 2, and we know A is 3. So we can use those values to find B, solve for B. So we got 4 equals 9 minus B squared. Minus 9 minus 9. Negative 5 equals negative B squared. Get rid of the negatives. We could square root both sides, right? Get square root of 5. The major axis is horizontal, which we knew from our sketch, right? So we can use the horizontal equation. Oh, it's right here. So this one, right? So the a squared will be under the x term as opposed to the y term because it's horizontal. Let's write that here. Because it's horizontal, we're going to use, where is it? Major axis horizontal, x. And basically we just have to fill in all these different values, right, to find the equation. So what do we know so far? We know the center, right, is 2, 1. The center is HK. So H is 2 and K is 1. That comes from the center, which we had already figured out. So start plugging in what we know. We have x minus 2 squared over a. We know a is 3 squared, plus y minus k squared over b. We just found that, square root of 5 squared equals 1. Simplify a bit. X minus 2 squared over 9 plus y minus 1 squared over 5 equals 1. And that is our simplified equation for that ellipse. Example 2. We're going to sketch this ellipse given to us, 4x squared plus y squared equals 36, and then also given the center and vertices after we graph. The vertices being the points at the end of the major axis, right? So, because everything we've seen so far has a standard model, right, for an ellipse, and the equation is equal to 1, we can see that this equation they gave us is in general form. This does not match up to the standard form that we're familiar with so far. So what we have to do is change this to standard form, right? So we'll start by getting that 1 on the right side. I can divide by 36 on both sides of the equation. So that means we're dividing every term by 36 here. So we'll start with that. It's going to be 4x squared divided by 36 plus y squared divided by 36 equals 36 divided by 36. Okay, this will give us our desired 1 on the right. And we can simplify the left side as well. This would be x squared over 9 plus, this stays the same, equals 1. Now that it's in standard form, we should be able to kind of extract all these different things that we just learned about, right? What is A, what is B, what is C, what is H, what is K, all that stuff. We know that, but before that, let's decide, is this a horizontal ellipse or a vertical ellipse? What do we know about a horizontal ellipse? We just did one, right? What did you notice about the numbers under the x and y terms? When it's horizontal, the larger number is under the x. That makes sense? That's when it's horizontal, right? When it's a vertical ellipse, then the larger number will be under the y. So based on that information, this ellipse is what? Horizontal or vertical? Vertical for sure. And because of that, we can extract now a bunch of stuff, right? So now that we know it's vertical, we know that this is the A value. We know that this is A squared, right? Because it's vertical, so A squared must be on that side, which means B squared is on the under the X squared. This is B squared. Is 9. This means that A is 6, B is 3. What else can I find with A and B? We have a formula for C, right? It was C squared is equal to A squared minus B squared. C squared is equal to A squared minus B squared. A squared was 36, B squared was 9. What is this? Oops. Sometimes it freezes up. Like that. And if we want C, we can do the if we want C, we can do the square root, right? Let's do it like that for now, because I don't think we need it actually, but it's good practice just to know that we can find it. Since I know that what the major axis measurement is, and we also know what the minor axis measurement is, we can actually already sketch this out, right? But before we do, what about the center of this ellipse? Where's the center? So up here, the center was 2, 1, right? And we can see it here in the standard form. Minus 2, minus 1, this was minus H. H is 2, minus K, K is 1. So center is at 2, 1. But if you notice for this one that we're trying to graph, the x squared and y squared are by themselves. So technically it's like x minus 0 squared and y minus 0 squared. So therefore the center is at the origin. That. Okay. And that's enough, I think, to sketch it, right? Because we have the center and we know already the major axis. So if I sketch it, which is what they asked us to do, I know the center is here. Then I know that the major axis is vertical, and I know that the distance on each side is going to be 6. So this is 6 this way and 6 this way. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And to the side, it's going to be 3. B is 3. So our ellipse looks something like that. And what did they ask us for? They said draw it and then identify the center and the vertices. So the center we have there, vertices. These are the endpoints of the major axis. So 0, 6, and 0, negative 6. Are these vertices. And that's all they asked for. We did find C, even though we didn't need to. What would that have been used for if they had asked us to find also what? What else was there? Center, vertices, and what's in between here? The two foci. So C actually tells you how far to go away from the center to find the two foci. So you would go, this is what, about a little bit more than 5 units, right? Since square root of 25 is 5, a little bit bigger. So 5 point something. So from the center to find one foci, you would go up a little more than 5. Foci would be right there, and the other one will go down. Foci would be right. But they didn't ask for that, so we technically didn't have to find C. But when they do ask you to find everything, all the components, then you will need to find C. Let's see, let's try example 3. Another sketch. Sketch the ellipse x squared plus 4y squared plus 6x minus 8y plus 9 equals 0. Find the center, find the vertices, and find the foci. So for this one, we do need everything. Okay, and this equation is a lot more complicated looking than the last one. It is in general term, not in standard form, right? It is in general terms. You can see it's not equal to 1 and so forth. So we will have to change this first to standard form, and then we can continue on to find A, B, C, and give all the stuff they want. So let's start by we're going to have to complete the square to get the two terms that we want, the x terms and the y terms. So what we do here is we gather all the x terms together and the y terms together, and then we move all the constants to the right side to kind of move them out of the way, and then we'll complete the squares first, and then we'll talk about getting the one on the right. So I'm going to start by moving my x squared here with the 6x, leave a space so we can complete the square, and then the y terms, 4y squared minus 8y, leave a space, and then the constants of plus 9, move that to the right side, so it's going to be minus 9 now. So to complete the square on the x's, actually before I do that, let's factor out what we need to So before you can complete the square, remember that you need to factor out whatever constant is in front of the square term from both your y terms first. Here we don't have, for the x's, we don't have a constant in front of the x squared, so that we don't have to worry about. Let me just bring it down. So it'll come back down like this. But over here, I can take the 4 out, and it would look like this. Okay. We do need to get those single terms, a single x term, x squared, single y squared, before we actually complete the square. Now we can complete the square. So we take the coefficient for the single x and single y variables, and we divide it by 2 and square it. So 6 divided by 2 is 3. 3 squared is 9. And negative 2 divided by 2 is negative 1. Negative 1 squared is positive 1. Like that. But these numbers I'm inputting here, I can't just input them because I feel like it, right? I need to balance them out on the other side so that this stays an equation. So once we've completed these two squares, I need to balance the equation out by doing the same thing on the other side, right? So here, if you notice, I added a 9, so I'm going to add a 9 on the other side. And over here, when I completed the square, I added a 1, but it's not really a 1, it's actually a 1 times 4. So it's actually a plus 4 over there. Okay, so be careful with that when you have a coefficient out front that is multiplying the number. Now we can simplify the next step. So before I factor these, let me rewrite everything. So I have x squared plus 6x plus 9. Then I have plus 4 times y squared minus 2y plus 1 equals, and then these cancel, so I end up with 4 on the right side there. This we move this one, right? Okay. Now we can talk about factoring. So this is now perfect square. This is now perfect square, so we factor them. We have x plus 3 squared plus 4 times y minus 1 squared equals 4. And you can kind of see, right, it's kind of starting to get that look of the standard form little by little. So what's next? So now this is, these are nice and factored. Let's get our 1 on the right now. So we'll divide everything by 4. The first term stays the way it looks. Over here, the 4's will cancel. So this is just over 1 and equals 1. So finally, we have standard form. And can you tolerate, is this a vertical ellipse or a horizontal ellipse? Horizontal because the 4, the larger number, is under the x term. Good. Change colors here. So we know that this is a squared. Oops. We know that this is b squared. And they did talk about foci, so we will need to find c squared here. C squared is equal to a squared minus b squared. C squared is equal to 4 minus 1. 3. So C is equal to square root of 3. So just keep that in mind because we're going to need it later. And we also know that A squared is 4, so A is 2. B squared is 1, so B is 1, right? Square root of 1 is 1. What's the center? Negative 3, 1, good. Negative 3, 1, which means H is negative 3 and K is positive 1. Yeah, good. Yeah, remember this is X minus H, right? So since it's plus, it would be X minus 3, it's plus. 1 minus 1, so the 1 is after the minus, so that's good. And I think that's everything we need, right? We just need to list it out. So let's sketch it first. We know the center. Negative 3. Up 1. You know there's the center. A is 2, right? So first of all, we know that the major axis is horizontal. So A is left and right. A is 2, so that's going to be 2 this way. And 2 units this way. B is 1, so that's 1 unit this way. And 1 unit this way. So we have something that looks like that. And then we still need the foci, right? So the foci is C. We take C and we add it to the center. So to go one direction, and then we subtract it to go the other direction. So technically, foci will be the center, negative. The foci is always on the major axis, right? So it's horizontal. So it's going to be negative 3 plus square root of 3 and 1. And negative 3 minus square root of 3 and 1. Square root of 3 is roughly like 1.7, so we're talking about negative 4.7-ish. So somewhere over here. And the other one's going to be somewhere over here. Right? Vertices. And for these, do use exact values. So instead of making this a decimal and adding a decimal to this, that's probably rounded, use exact values like this. Unless they specifically tell you, enter your answers as rounded decimals. Vertices, these are the endpoints of the horizontal axis for the ellipse. So our vertices are what? Negative 1, 1. And 2, 3, 4, 5, negative 5, 1. And I think that's everything, yeah. Center. Foci. Vertices. And then our sketch. Okay. So most of the work is really just getting into that standard form. But once you get here, everything else is pretty straightforward. You have A, you have B, you can find C, and that gives you everything you need, right? A to find the vertices, the center, of course, will be in your equation. A to the left and right gives you the major, the vertices, and then of course B is your up and down on your minor axis. And of course, once you have C, you use that by adding it to the center and subtracting it from the center to get the foci. Now, just keep in mind that to find the foci, where you add the C value is going to depend on whether your ellipse is horizontal or vertical, right? Because it's horizontal here, we added and subtracted from the x value. But if it's a vertical ellipse, you're going to add it and subtract it to your y value, okay, to get those foci points. So one more of those. Sketch. This one I'll go a little faster since we done two of them already. This one is going to be the same thing, but different equation. Sketch 4x squared plus y squared minus 8x plus 4y minus 8 equals 0. And then give the center and vertices and foci, etc. Okay? So remember, we're going to group the x terms together. Leave a space for the when you decide to complete the square. Y terms together. Leave a space. Constants on the other side. So minus 8 becomes plus 8 on the right side. Factor out any constants from the two like terms that you have in front of the x squared, right? So 4x squared, for example, factor out the 4 from these two. So whatever's in front there. Leave a space. The y does not have one, so we just rewrite it. Once that's done, we can complete the squares. So it's the coefficient that's in front of the single x and the single y. You divide it by 2 and square it. So 2 divided by 2 is 1. 1 squared is 1. 4 divided by 2 is 2. 2 squared is 4. And then whatever you added here on the right side to complete the squares, we do the same thing on the left side. We do the same thing to the right side. The first one is a plus 1, but it's actually a plus 4 because of the 4 that's in front that multiplies it. The second one is a plus 4, and that is actually a plus 4. So just add 4 on the right side as well to balance out the equation. Now we can factor. Simplify as well. So this is 4 times, this is now a perfect square, x minus 1 squared. And remember, they're always going to factor perfectly because that was the whole point of completing the square. If for some reason you can't factor it perfectly, that means you completed the square incorrectly. 8 plus 8 is 16. And next step, we're getting closer to that standard form, so now we just need the 1 on the right side. So we will divide everything by 16. And reduce as we go. So this is x minus 1 squared. 4 goes into 16 4 times. The next one is just rewritten. Equals 16 over 16 is 1. Horizontal ellipse or vertical? Vertical, the bigger number is under the y, good. So this is our a squared. Value, and this is our b squared value, which means that a is 4. Is square root of 4, so that's going to be 2. We will find c since they do want the foci. So c squared equals a squared minus b squared. C squared is equal to 16 minus 4. C squared is equal to 12. So c is square root of 12. So we have a, b, and c there. What's our center of the ellipse? Values with our x and y. This will be 1 and negative 2. 1 and negative 2. Good, so that's our HK, H and K. And then vertices and what was the other thing? Foci. So foci we can actually figure out without the drawing, right? So we have the C value that we have to add to get the foci, and we add it to the center, right? Is the foci on the vertical axis or on the horizontal axis? Yeah, vertical. It's always on the bigger one, right? So the C, we're going to add this and subtract this from the Y. So it's a vertical ellipse. So we'll do center here. So this is 1 and -2 plus square root of 12, and 1 and -2 minus square root of 12. Those are the two coordinates for the foci. And all we need is the vertices, right? But we can get those when we sketch. So sketching, center is at 1, -2. We said it's vertical, so A is 4, so go up 4. 1, 2, 3, 4 is here. Down 4, 1, 2, 3, 4 is over here. Sideways from the center, we go B units. B is 2. 1, 2. 1, 2. So something like that. So our vertices are the endpoints of the major axis, right? So we got 1, 2, looks like, is the top one, and the bottom one is 1, -1, 2, 3, 4, 5, 6. Like that.